This lesson shows how to use the quadratic formula to solve quadratic equations. In a previous lesson, you learned for a quadratic equation in standard form, there's a formula for the solutions called a quadratic formula, where a is the leading coefficient, b is the linear coefficient, and c is the constant. Using a formula is a pretty straightforward process, but there are some potential mistakes to watch for and some other things to notice about the formula. Be careful when the linear coefficient is negative. There are two places in the formula where it's easy to make a mistake. For this example, the leading coefficient a is equal to 1. The linear coefficient b is equal to -6. And the constant c is equal to 8. Then negative and -6 is positive 6. -6 squared is positive 36. And 4 times 1 times 8 equals 32. Next, 36 minus 32 equals 4, and radical 4 is equal to 2. And the solutions are 6 plus or minus 2 over 2, which gives 6 plus 2 over 2, which is 8 over 2. And the first solution is 4. Then 6 minus 2 over 2 is 4 over 2, and the second solution is 2. Be careful when the constant is negative, because the expression under the radical sign becomes a sum. For this equation, the leading coefficient a is equal to 1. The linear coefficient b is equal to 2. And the constant c is equal to -8. Then 2 squared equals 4, and -4 times 1 times -8 is positive 32. Notice the expression is now a sum. Next, 4 plus 32 equals 36, and radical 36 is 6. And the solutions are -2 plus or minus 6 over 2, which gives -2 plus 6 over 2, which is 4 over 2, and the first solution is 2. Then -2 minus 6 over 2 is -8 over 2, and the second solution is -4. For this equation, the leading coefficient a is equal to 1. The linear coefficient b is equal to -5, and the constant c is equal to 2. Then negative a -5 is positive 5, -5 squared is positive 25, and -4 times 1 times 2 is -8. Finally, 25 minus 8 is 17, and the solutions are irrational. 5 plus or minus radical 17 over 2. Using a calculator, radical 17 is about 4.12. So the solutions are approximately 4.56 and 0.44. When the radicand is not a perfect square, the solutions are going to be irrational. On the other hand, when the radicand is a perfect square, the solutions are rational. For this equation, the leading coefficient A is equal to 1. The linear coefficient B is equal to -6. And the constant C is equal to 10. Then a -6 is +6. -6 squared is +36. And -4 times 1 times 10 is -40. Finally, 36 minus 40 is -4. And the radicand is negative. Since the square root of a negative number is not defined, there are no real solutions. Actually, this equation has complex solutions, but you'll learn about that in a later course. Also, you can see from this example and the prior examples, the radicand is an important part of the formula. For the quadratic formula, the expression under the radical sign, the radicand, is called the discriminant. From the examples in this lesson, you can see when the discriminant is greater than 0 or positive, the equation has two real solutions. When the discriminant is less than 0 or negative, there are no real solutions. When the discriminant is a perfect square, the solutions are rational. And when the discriminant is not a perfect square, the solutions are irrational. Also, the discriminant could be 0, in which case there's one real solution. Here's an example of a quadratic equation with only one solution. The leading coefficient A is equal to 1. The linear coefficient B is equal to 8. And the constant C is equal to 16. Then 8 squared equals 64. And -4 times 1 times 16 is -64. Finally, 64 minus 64 is 0. And there's only one solution, -8 over 2, which is -4. This lesson showed how to use the quadratic formula to solve quadratic equations. And this lesson was brought to you by the Math Fun Academy. Its continuing mission to explore strange new worlds, to seek out new math and new equations, to boldly go where no math student has gone before.